Okay, so this is going to be an introductory video for Introduction to Statistics, not much of a prerequisite. So whenever you take elementary statistics, probability and statistics, it goes by many names, introductory or elementary statistics. There's always some level of algebra prerequisite, but not really. So people come into the course, from all different backgrounds in math, usually basically none, which is okay. So the first one, two, or three videos, if we want to skip these videos, it's perfectly okay because we're going to kind of review some stuff here that doesn't have a whole lot to do with the course. I just want to cover the course comprehensively. So this is video one. The goal is going to be to comprehensively do an entire introductory to statistics. We don't really need to write all this stuff, yeah. Intro stats, also called elementary statistics. Yes. So the goal of this video series, and if we get to the end, it will take many, many videos, dozens, maybe hundreds, because it's going to be very comprehensive. But we are trying to complete we're doing a video series trying to complete an entire elementary statistics course from beginning to end. So this is a video one, which is just an introduction, and it'll probably take more than one video. So the first one or two videos we can skip if we want because we don't really need them. So I'll try and label them in the title and the description. But this is a problem series number one. What is the introductory video? It contains my little introduction here, and we'll just jump right into it now. And it's going to do some of the prerequisites, which we do right now. They just ask us a few questions to get used to the program. Okay, so these are literally some prerequisites. I feel kind of a little bit silly going through some of this stuff, but we have to know this for the course. So feel free to skip the video. But this is true in math. You know, most of this entire homework series is talking about definitions. Yeah, letters that represent numbers are called variables. Let n be the number in thousands of residents who watch a parade. What does n equals 20 mean in this situation? Let n be the number in thousands of residents who watch a parade. So, uh, of course, we're always trying to be organized, which is very difficult. We will go straight through the course. We go straight through the entire course from beginning to end. It will be somewhat organized, but a few things along the way will be taught in kind of a unorthodox order. I can't really help it because um, it can just be, kind of difficult to organize the class. So it will be approximately in the order that it should be, but, not randomized, but some things will be kind of misplaced. But as we go through, we talk about some of the concepts. So this comes later. We will go through this later, guaranteed. We just talk about it as it comes. But N is something very specific. It is sample size. Yeah, it is much more important. Please do not confuse it with capital N. Yeah, capital N is literally the size of a population, if by chance you do know it. Quite oftentimes in statistics, we don't even know what capital N is. But capital N this is universal across all classes. Capital N is population. We get that very little or none. What we always get is little n, which is sample size. But n equals 20. Of course, n equals 20, that's perfectly fine, but they just want us to kind of read and interpret. Specifically in this one, they're asking is we know that n is 20,000, which it is. Okay, so let d represent the distance in feet from sea level. Okay, so that's interesting there. So of course we've already gone through that, but they're having us do a number line. They do this a little bit and it confuses people because sea level is 0. So anything above that, of course, is a positive number, yeah. But if we go way below, if we're going to be 11,965, yeah, below sea level, they're going to mark it as a negative number simply because, yeah, that's negative. Okay, so this is fun. Convert that to feet. It's not chemistry, but math, physics, and chemistry. And all of it, we learned the unit conversion. We have this many miles, convert it to feet. Yeah, we have to know how many miles are in a foot. Yeah, so what we literally do there is 6.8 times 5280. We're not doing anything here. We just do it on the calculator. Okay, good. So, yep, all the introductory stuff is just silly little exercises. So it's probably better to just skip this. So we want to kind of say this, every little thing is kind of a speech and it goes a little bit outside the course. We just kind of have a new idea with each thing here. But we don't need SI units from this course. I say something, maybe this is kind of a little unusual that we say it, but most people know that we have a little something called the metric system. Yeah, hopefully we don't slaughter spellings here. Yeah, SI, it's backwards because it comes from, I don't know what it is, French or something. But this is the international system. Yeah, SI is international system. And it's used mainly in physics. The international system, which is used universally, is a math, physics, and chemistry. It is math, physics, and chemistry, SI units, but chemistry can use something a little bit different than physics. When I think SI, I think physics. When I think physics, I think SI. It is the international system. Now, we don't just want to make stuff up. I don't want to say the metric system is contained within SI. The metric system is contained within SI units. It doesn't really work that way. I still don't know because we never get around to looking it up. We don't care. The metric system and the international system are fairly different. They're just two different things, but they're also very similar. So the only thing that we care about is for the most part, both of them go by 1,000. So you have metric and you have SI. Exactly what are we doing? We never have to, let's say we have a gram, we never have to define this very well, whether it's SI or metric. The only reason I said all that is because whether we're using metric or SI, it simply doesn't matter. But we know that 1 kilogram is going to equal 1,000 grams. And yes, 1,000 is 10 cubed. And then that's all we really know. We don't go above that. But 1 megagram, 1 mega is 10 to the 6 or 1 million grams. We go down here, yeah, and it's harder over here. Yeah, but how do we write that? Yeah, so one milligram is going to equal 10,000 grams. I'm sorry, 1,000 grams. And it goes down below. And then, we have centimeters and all that in there as well. But you can always just literally metric or SI or unit conversions. You can Google image several things that will, give you this information here.